What's a software? What's a software? And that's what we'll talk about next. What's a software? So you are aware what's a software, right? I mean, it's basically a set of programs, right? That's what it is. A set of program that is working together to do something meaningful to you, right? I mean, right, it's solving some of your problem that you are facing. You have a calculator application in your laptop, and what is it's nothing but a set of program, and then it can solve a lot of mathematical problem that you are facing. You want to, if they without calculator, if you want to do a multiplication or division or kind of complicated operations, it is much time consuming and much boring, maybe not, but yeah, the point what I'm trying to make here is that all the softwares are a set of program, and they work together and try to solve a problem what we are facing, right? Think about the Microsoft Word. When we think about the Microsoft Word, technically, Microsoft Word consists of various options that makes your story looks better, right? It looks it provides you a proper view to your story or your article, whatever you write inside, right? I mean, you want to share some document with somebody else, and you want to highlight the points, you want to put some data inside a table, or you might want to do a lot of text formatting to be done, and you can use Microsoft Word to do that. And Microsoft Word has various options. When you option to make bold message, I mean, your text can be turned into bold, italics, underscores, underlines. Then you can increase the size, decrease the size, you can change the font. There are a lot of things that you can do. And every time you click on some button in the Microsoft Word, you click on the bold button, a set of program get executed, or some program get executed that would change the selected text to bold. Or you click on the underlines, then the selected text would consist of underlines. By executing, internally some programs get executed inside the Microsoft Word. So technically, a software, you can assume it's something that you use, and it's something that you click, or it's something you interact with, right? You click with a mouse, or you click type in something on your keyboard. You are interacting with the software, and as you interact, some program get executed in the background. Sometimes, without you doing anything, some program automatically get executed in the background. Some kind of background programs that Microsoft internally manage the Microsoft Word may be executing in the background. And apart from that, most of the time when you interact with the software, when you click the bold button, when you click the underscore button, when you click the italics button, then some programs get executed in real time as a result of you interacting with the software. And that's what a software is. Software allows you to interact. Software allows you to get things done, whatever things they are, right? You can just by interacting or by passing some data, you can talk to the software, and a software will solve some of your problem. And technically, in the background, a software consists of a lot of programs, various programs, and based on what you click, a respective program get executed. So that's what a software is. Software is a set of program meant for solving a problem that you are experiencing in real life, right? It could be a mathematical addition, or it could be a text formatting, or it could be a searching for some stock value on the internet. There are various problems that you are facing, and there are various software that you use on a day-to-day basis to solve those problems, right? You use Google when you want to learn something new. You always use just you use a Word when you want to do some text formatting to be done. You use Facebook when you want to connect with the people, or you use Instagram when you want to share a story with the other people. So there are always a lot of software on a day-to-day basis that you use, and all these software solve some of the problems for you, and that's why you are using them, right? So that's the purpose of the softwares. They consist of a set of program meant for solving a problem, right? Great. What is a web application? So the next question, what's a web application? Web application is also a type of a software which can be browsed over an HTTP URL. Think about google.com, right? You can browse for google.com, and it's a software. You can assume Google to be a software. Do you agree with me? Because it consists of a set of program, and it is trying to solve some of the problem that you are experiencing. I don't know something, I want to search in Google. Google tells me the answer. So Google is solving some of my problem. And when I use Google, a lot of programs are getting executed internally. For example, I click on this search button, then a pop-up has appeared, and it tells me all those search history that I had used. And then I search for something, then I click on this search button, Google search button, then it is giving me a lot of results, right, in the next page. So every time I click a button, or every time I move my mouse cursor or click my mouse cursor somewhere, looks like some programs are getting executed somewhere, right? It could be in my laptop, or it could be in my browser, or sometimes it could be on a remote server. It doesn't matter, right? It's set of programs that get executed based on the button that I click. I click on this voice button, it's a different program that might get executed. I click on this search button, it could be a different program. I click here, it could be a different program. So it all depends on where I click or how I interact, right? A set of program get executed in the background. So you can assume google.com also to be a software, and except that the google.com has a good looking UI, right? When you browse google.com, it has a logo and it has a proper style, right? And I like the style. And the logo comes on the top, then there's a big search box where I can type in, whatever I want to search, and then I can click this button, Google search, or I can click enter button in my keyboard, and then some program get executed in the background. So it has a good looking UI that makes things easy for me to use the software, right? I don't have to bother about what programs are getting executed in the background. I never cared, right? I never cared when I want to search for something in Google. I never care about Google's technology, how they are printing me this website onto my browser. And when I search for something, what happens in the background, I never bother. I just use it and it just works for me. And that's what a software should do to you, right? Softwares provide you a UI that using which you can interact with the software and get things done, right? Solve your problems, and that's what the softwares are for. And behind the screen, a lot of programs get executed, and a lot of style get changed on the UI, right? The UI changes. Search for something, now I see the UI that has a logo in the middle, but after I click the Google search button, the logo is on the left side, and here the UI has changed. So basically it is interactive. A lot of interactions are going on. The UI changes, the background programs that get executed changes based on where I click and what I do, right? So that's what a software is. It's arranged in such a manner that it's I'm able to use it very easily, and that's why I the UI should be great when you are creating a software or a web application. Google.com is a web application. Any software that can be browsed on a HTTP URL, that may be that will be an example of a web application. It does not has to be browser is not the only tool that can speak to an HTTP URL. You can use a different other tools also. So there should be an HTTP client. In general, you can call it HTTP client, and most commonly it could be a browser, right? So using a browser, you can connect to the applications, like you work on the application. Such kind of applications are called web applications, web-based applications, or HTTP-based applications. And technically, it's you on your computer, and then there is some server of Google which is communicating to your browser. Your browser is speaking to some machines at Google, and then they are interacting to each other, and they are talking to each other. They are transferring the data, the search result they are transferring, the Google logo, the style, the UI they are transferring, right? So a lot of files are being sent to my browser from the Google server, and a lot of data being posted from my browser to the Google server. So they are talking to each other. So technically, when we talk about a web application, it would consist of an HTTP client, which you can call a browser is an example of an HTTP client, and then there would be an HTTP server. So in our particular case, when we think about google.com, we can consider this to be the Google server sitting somewhere, maybe in Mumbai, maybe in Delhi, I'm not sure, right? Wherever it is serving me. So this is me sitting in my laptop on my browser. I opened my browser in my laptop and I browsed google.com. Then my browser somehow browser identified that this is the machine that it want to speak to, and the machine could be sitting in Delhi, not sure, or it could be in Mumbai, it could be somewhere else. Wherever it is, my browser somehow figured the IP address of this machine, connected to that machine, and asked the machine, hey, I need the web page of google.com. And then what the machine did is it provided the UI to my browser that consists of all those HTML file, style sheets, then those images, the Google logo, and maybe some programs also. So HTML, CSS, and images, these are the static content that the browser understand, right? So the Google developer, when they want to develop the Google UI, right? When I say Google UI, I'm talking about this page, right? This whole page I'm talking about. So so Google has to specify, first it should print the logo, then it should print the search box, then it should consist of two buttons, and this is the text that should be displayed on top of it. So they write HTML files to do that with some styling, and to do the styling they use some CSS style sheets, some kind of documents they write, and then the logo image they will embed in it. So all these things are possible, and those HTML, CSS, and images will be given to the browser, and browser understand those styles. Browser know how to display an HTML file. So whatever Google developer have written inside those HTML file, the browser, once the browser got those HTML files, the browser know how to display the HTML file. It will print all those styles or designs, whatever Google developers have created. So that's how it works, right? So a website UI is all about HTML, CSS, and images, some static content. Images means photos, logos, or whatever. Then optionally, there would be some programs also that will be sent to the browser. So these many things UI consists of, these many things. Some programs, they are JavaScript programs. JavaScript is a programming language which browsers are capable to execute, right? All browsers nowadays are capable to execute JavaScript programs. The browser can display the HTML file. Apart from that, the browser is also capable to execute some programs. Yes, front-end programs. Yes, now probably whether you are aware it or not, the browser also executes certain programs, right? Which we will get into later. But yeah, so initially when you browse for this google.com website, your browser speaks to the Google server and asks the Google server, and it's called an HTTP server. And then your browser is called an HTTP client. This is an HTTP client. That's your browser. So HTTP client will speak to the HTTP server, ask the HTTP server, hey, I need the google.com page. And then it will send all the data to the HTTP client, including the static data. When I say static data, I'm talking about HTML, CSS, and images or whatever. Then some programs also. These are called front-end programs or JavaScript programs, whatever name that you want to call it. They are written in JavaScript programming language. That's the only programming language that browsers support. So if you are a web developer, if you want to develop a website, the front end should be developed in JavaScript programming language. That's the only programming language browser understands. So that's a programming language every web developer should learn, right? And browser is will be executing them later. And then inside the server also there would be all this content, static content is there, which will be served to the browser. Then apart from that, there would be some programs which we can call the backend program. So I will tell you the difference between a front-end program and a backend program through this example. I'm going to browse google.com, right? I'm going to browse google.com. So I browse google.com. Then what my browser did is it connected to some server of Google. Then I got this web page printed on my browser. I'm clicking this search box. Then it is showing me my browser history. These are some search I did in the last few days. So it is showing me the list. So do you think so? Obviously, some program got executed, right? The pop-up was not there earlier. As soon as I clicked my mouse cursor in the search area, this pop-up has come. Do you think, yeah, some program got executed? That is for sure, right? Otherwise, this won't happen. Some program got executed, but the question here is that who do you think executed this program? Is it your browser or is it the Google server? That's the question here. So actually, I am assuming it's my browser because all these are my browser search history, and definitely Google have no idea. Google may, but yeah. Today, let's not talk about that. But right now, I know that all this search history, whatever search I made, everything is showing up. So how would Google know what I searched for? Right, so these searched are from my browser history, and somehow some program that my browser executed fetched my browser history and showed me the last 10 searches. So I am assuming, in this particular case, I am assuming that whatever program got executed, as soon as I click this search box, some program got executed, but the program got executed within my browser itself. And I do not think the remote Google server is involved in this process, because Google server don't know what did I search in the last 1 hour or last 10 keywords that I searched in Google. Google server wouldn't know. So I think I think this search, this happened within my browser. And yes, so within the browser there are some programs. Yes, the programs are originally developed by developers of Google, JavaScript programs, and then it was sent to my browser. And it looks like, they are configured to run when I click on the search box. That is smart move. And then now the next thing, I'm going to search for something in Google. So I click on a keyword and I click on Google search. Then I got some search results. So definitely this is not something that my browser did. It is telling me a lot of information about cricket and about various other information it is printing me. So looks like Google executed some program from their side, figured out what are the search results, and they figured out these many search results, and the first 10 or 15 are being printed back to my browser. So this data definitely my browser don't have, right, about the cricket or about whatever going on about around this keyword test. I have no idea. It's but only Google knows that. So I know that this time when I click the Google search button, some program got executed. Maybe my browser posted this message to the server, right? My browser sent a message, posted this message test to the server, and the message received at the server, and then some backend program got executed on the Google server, and as a result, it probably those program connected to some database, and from that database it fetched a lot of results, these many results, which I cannot even know how to count it. So those many results it connected to a database, fetched from it, and it is printing me on my browser. So definitely it's Google did this, not my browser. All right. So the point what I'm trying to make here is that you need to understand, for every website there would be front end programs and backend programs. The front end programs are developed by Google developers, the front end developers of Google, and they are configured to be sent to the browser and get executed within the browser itself. And on the other end, there would be backend programs, and the backend programs can be executed on the server. They get executed in the server based on the browser interaction with the server, based on a user clicking a mouse or user pressing the enter button in their keyboard. So basically, whoever user is working on google.com website, when they click on some button or when they do something, a message would be sent to the server, and then server execute some respective programs and give a response to the to the HTTP client, in our case, the browser. So browser and server speak each other, transfer the data, send requests, get responses, and that is how a web application works. And there would be backend programs that get executed inside the server, and then after executing the server would send back the data to the browser, how it should be displayed. And similarly, the browser sometimes post data to the server, request the server to execute something, and that's how a web application generally works. And always remember, the server program can be written in any programming language. It could be in Java, it could be Python, or you can use any programming language to write the server programs or the backend programs, Java, Go, Python, PHP, whatever programming language of your choice. There is no problem. But when you are writing a front end program, it should be written in JavaScript. That's the only programming language browsers understand. If you want browser to execute something, it should be written in JavaScript programming language. That's the only programs that browser is capable to execute. And that's the point. That's how a web application works. And next session, we will talk about a microservice and how microservices works. And we will also demonstrate some microservices to you. That's the plan for next session, things like that. So yeah, let's talk about what is a microservice, right? I mean, yesterday we discussed about what's a software and what is a web application, and today let us talk about what is a microservice, right? Mm. So a microservice is basically it's nothing but a software application, but it is not developed as a single piece of software. It is developed as uh, decoupled applications, and they talk to each other using some network, right? So the technically, think about a company who developed one single complicated application, and that is how most of the companies are doing nowadays. They develop the monolithic applications, and this monolithic application consists of a lot of moving parts, a lot of dependencies, a lot of function calls that is happening between them. And over the time, these applications can become more and more complicated because the software complexity increases as soon as the business complexity become more and more, right? Every time the business expand, software complexity increases automatically because a lot of new features need to be added to the software. So every company need to keep on adding a lot of new feature to the software. So that is why it is a ever ending process. Software complexity become bigger and bigger. So if you develop a single monolithic piece of software, then the software can become terribly complicated that you would be much afraid to make any changes to that particular software. So instead of that, nowadays a new strategy have been developed. Many companies are following that strategy. Rather than developing one single monolithic application, you will split your application into small components. For example, if your company is developing an application for a hospital, then probably the doctor booking the doctor is one process inside the hospital, and then probably arranging the medicine for the pharmacy is another process. Then a doctor taking appointment with the patients is another process. So you can actually kind various domains within your business or within the domain whatever you are operating. So based on that, you will find out which domain is independent of other one. For example, the pharmacy domain could be independent of the doctor booking domain. So they can be decoupled because there is not much dependency between them. So what software developers will do is, or what the companies will do is, they will develop the doctor appointment system as one single piece of software. Then the pharmacy software would be a different piece of software, and both these softwares are developed by independent team, autonomous teams, and individual team have full control on whatever system that they are operating. So it's the same software, it's a hospital management software, but within the software, rather than managing it as a single complicated software, you decided to split various business domains and develop different softwares. And when they want to send some data, for example, the doctor booking appointment systems or the pharmacy system want to read something from the doctor appointment system, So it will make a API call, or it will make a network call. Using a network, they will talk to each other, or using HTTP call, they will talk to each other. So basically, a microservice based application is technically a single software. It consists of various microservices, and each of these microservices can be considered as a independent software, and it is managed by individual team within the company. Or if you think about a company like Flipkart, maybe the shopping cart management could be one software, then prime customer management could be another software, order management can be another software. So like that, there you would develop various softwares, and all these softwares at the end, they will run inside some machines, and every time they want to transfer some data, they will not make any function call. Generally, that is how various functions within the software communicate. They make function calls, right? So in this particular case, they won't make any function call, because this is one software. Shopping cart is one software, then prime customer is another software, and then over here, order management is another software. So like that, these are all autonomous independent softwares developed individually by separate autonomous teams. And then and then all these softwares, when they want to pass some data, they will communicate over a network using HTTP or some networking protocol. They will talk to each other, and they will transfer the data. For example, the shopping cart want to talk to the prime customer application and ask the application who whether the customer who is creating the shopping cart is a prime customer or not, right? Something like that. So there can be a lot of various dependencies or data transfer that want to happen between the application. So they will talk to each other over a network. And so that is why when you run the software inside various machines, and most companies uses cloud nowadays, so assume all the softwares you are running inside some virtual machines in the cloud. And then this machine should have connectivity, network connectivity. The machine should be capable to talk to each other, because software that you are running inside, they want to speak to each other and transfer some data. So this is the way how microservices work. And when the company develop the microservices, it would be done by separate team, right? One team would be developing and managing the order management software, and then a different team would be developing and managing the shopping cart software. So like that, there would be a number of autonomous team, independent team. They don't have to depend on others, when they want to make any changes to the respective software, right? Order management software, since it is independent of other software, this team has all the flexibility to manage the software. So if you are developing a microservice, your company can keep small teams, right? There is no need to expand the team, no need to maintain 30 people team, which is very complicated process. If you want to manage a 30 people team, or 30 people want to work on the same software, it's a complicated process. And microservices is a good idea. Most of the companies are nowadays planning to adapt it, because you can split your teams into small teams, like 5 people team, or maybe maximum 10 people team. Your team size should not be more than 10. So you can create such kind of small teams, and then each team can manage separate applications, and they can work independently, develop independently, test independently, deploy independently, release the software to production independently, right? So the same team will be responsible for the complete life cycle of the software, whatever they are managing. So that kind of flexibility companies would get, or you will get when you are using a microservice. So microservice is a good idea. And many companies, including Netflix, Amazon, they converted their applications into microservices, which works pretty well. It's you can easily make changes if you are using microservices. So that's the point. And yes, of course, they work together. They talk to each other over network protocol. It won't be function call. So what that also means is one application may be developed in one technology, other application could be developed in a different technology, because they don't make any function call. They always talk to each other using some protocols such as HTTP, right? So they can talk to each other without depending on each other technology. So maybe shopping cart is developed in Python programming language, prime customer could be developed in Java programming language. It's absolutely fine, because it's they are not dependent, right? They are not dependent, that's why it's not important. Great. Now let's demonstrate three microservices. So I'm talking about three software applications that is going to work together as a single final software, right? It's a web-based application. It's an application that people can browse on a browser. That is the kind of application that I'm going to demonstrate today. So for any application that need to be browsed on a browser, there should be a front end. There should be a front end that the people are capable to open using their browser. There should be static files, images, style sheets, and then some JavaScript front-end programs that the browser will execute. So there should be a front end, and there should be one or more backends. Right, in the backend, there would be some server programs that you want to maintain. So in my particular case, the application that I am going to demonstrate this to you, it consists of basically three microservices. One is a front-end application, then other one is, we call it backend one, which is a Java based application. And then we have one more application, we call it a backend two. It is a Python based application. So three microservices, three applications developed in three different programming language. Front end is developed using JavaScript, using React, right? Front end is developed. And the backend one is a software that is developed in Java programming language, and then we have backend 2 software, which is developed in a Python programming language. Somebody is unmute. Can you? Okay, so that's what I was talking about. So I'm going to demonstrate three applications to you. So I'm just talking about these three applications, not only running them on some server and making it available to your customer. Yes, you have to do that. You have to create various machines, and you should run the software inside various machines, and then you should your customers using their laptop. They should be able to browse your applications, and they should be able to see your application and use your application, just like Flipkart, Amazon, or Google. People all over the world will be able to browse my application using an HTTP URL using their browser, and their browser want to communicate to various software that I manage inside my company. And then all these softwares will be serving the customer, and giving him the appropriate responses when his browser requests for something. So this is what I finally want. And these softwares are developed and managed by my developers. So I have a team of developers, and my developers, what they do is they write the code and they develop the software. And actually, either a single team can do develop all the three software, or I can split the team into various, for example, for the front end, I can maintain a three people team. For the back end one, I can maintain a two people team. For the back end two, I can maintain a three people team. So like that, I can actually create three separate team, and each team can handle or develop one software each. And after they develop the software, for that, they all have a laptop, and inside their laptop, they will be coding, right? That's what they do inside their laptop. Everyone has their own laptop. So inside the laptop, they will do the coding, they write the code, and that is how they develop the software. And after writing the code, they have to do something. I mean, before the software become ready to run inside your service, there are a bunch of things that you have to do. After developing the code, you want to convert them into some executable file. There are a bunch of things that you have to do before this software what your developers are developing in their laptop would finally become ready to run inside your production service. So it's a process that has to happen. and it is not a very straightforward process. A lot of things need to happen before the software, uh, whatever software the developer develop in their laptop, in order to for them to become available to the production systems that your company maintain. A lot of process your software has to undergo. So we will talk about that. And first of all, we will start with a developer laptop. I'm going to show you the code of all the three applications. The plain text source code is what I'm talking about. If you right, that's what I'm going to do. This is my laptop. Assume I am one of the developer, and inside my laptop there are three different folders. One is the front end folder, backend one folder, and then backend two folder. I have three folders available within my laptop, and then I have another folder called resource manifest. That is another folder within my laptop. So I have these many folders available within my laptop. So each folder resemble one microservice. The front end code is there inside this folder. The backend one code, the Java code is available in this folder, and then the Python code is available in this particular folder. So assume this is a developer laptop that you are looking at, and it consists of a. This is I'm using VS Code. VS Code is a free software. Many developer uses VS Code to write the code, right? Because no, don't use Notepad or any other editors. No, VS Code provides you a proper UI and a proper a proper coloring and graphics while you are writing something. So, VS Code is a very good software. You can see, it looks good, right? Good coloring and lot of code review recommendations and lot of benefits, right? So most developers nowadays they use some kind of IDE when they want to develop the code. So in my particular case, I'm using VS Code, which is a free software. You can download them. You can download VS Code and you can install it on your laptop, and then any folder in your laptop you can open inside the VS Code. So always use VS Code, or at there are many other softwares. Don't use Notepad or Notepad plus plus when you want to write the code. And anyway, you are not the one who will write the code. I'm just demonstrating this to you, right? I want you to take a look at the code what your developers have written, and you don't have to worry about writing the code or developing the software. That's not your job, right? That's somebody else's job. But yeah, what I'm going to demonstrate here is that this is the list of software, and every software has set of code. So CoIT frontend is a JavaScript based software. You can see it consists of a lot of JavaScripts, right? Different JavaScripts are there inside this particular folder. You can see, right? Various JavaScripts are available, and then it consists of some HTML file, and it consists of some, some icons and images and things like that. So this is a front end application that my developers are developing, and the intention is that once the software is developed and once the software started running in my production environment, then this software will run on the customer browser. Any customer who browse for some URL, which I will provide to them, we'll talk about that later. But yeah, at the end my customer browse for a URL, and then they will see a web page displayed on their browser, and it need to consist of the HTML file, the CSS files, style sheets, right? We discussed about this, the images, and then a number of JavaScript programs also. And all these things need to run inside a browser. And yes, one of my developer on his laptop, he is developing all these things, the HTML, CSS, images, JavaScript programs, everything. He is developing it himself inside his laptop, and that's what he is doing, right? That's what he is doing over here. So this is the particular folder that consists of the front-end application. And this is the folder that consists of the Java application. You open this folder, you can find various Java programs. So this software is not supposed to run on the browser, but only in the backend. Browser will make a request to this software, and then this program get executed. So it's a Java-based software. And then there's a Python based software, and it consists of some Python programs and stuff. So three softwares that I have in my laptop. And what you are looking at is the plain text source code whatever your developers are developing, right? We are there, right? So we are not ready. We are not ready to run the software. We are just developing the software by writing the code. Not you, your developers are doing that, right? They are the ones who write the code. So you are currently looking at the code that your developers are developing, and later this software is going to run inside various machines in your company, right? Great. Okay, guys. So I'll just so that's where everything start. A developer write the code, right? So now let's talk about importance of artifacts. So I told you, a developer, whatever software that your company has to maintain and manage, it start from the developer. They write the code, they develop it, and but you already know only your developers are familiar with coding, right? Only developer are good with coding. Your operation engineers are not good with coding, right? You are not very good with coding. So developer write the code, they develop the software, and after they develop the software, this software has to run in some machines, right? It could be it could be a machine that you created in the cloud, or it could be a machine that you created on the premise, or it could be a machine of yours. It could be your laptop. Maybe you want to run the software just for the testing purpose. You want to run the software and make sure that the software is running inside a laptop before you run the software in the cloud. So there may be various places you want to run this software. So it's very important that every company, after they develop the software, they want to run this software in many places. I'm not talking about only in the cloud, which will serve your customer. That is not the case all the time. Sometimes your teammates want to run it on their laptop first, or your QA engineer want to do some testing using their laptop, so they want to run the software in their laptop. So there are many people, many systems. It could be in the cloud, it could be in the laptops. Whatever software you develop, you want to run them, right? You want to run them, and you want to run them many times, and every time the developer makes some code change, you want to run them again. So 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 your developers are pretty comfortable with the code, and they can deal with the code, which is good thing. But not other people. Your QA engineers are not good with the code. Your cloud server, when you want to install them, your operations team has to do such kind of job. They want to install the artifacts. So that is not an easy job either, right? So basically, what you need is a executable file. And if you have an executable file, you know how to install a software, right? I mean, you do that on a day-to-day basis on your laptop. If you have a exe file, you know how to install it, right? You don't have to worry about the source code when you install an exe file, right? Think about Mozilla Firefox, or some software that you want to install in your laptop. So you will go to the Mozilla website and you search for download Firefox. Then you got an exe file. You download that exe file to your laptop. You double click it, and then you click next, 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 and then Firefox got installed in your laptop. So that is how you install softwares in your laptop, right? Most of the time, at least most of the time, this is how you install softwares in your laptop. You are using some executable file, and you are double clicking on it, right? You don't bother about the source code. You don't bother about your Mozilla developers, how complicated their work is, right? You never bother about any such things. You have an exe file, you double click, you execute, and you run it, right? That's how you should run the software. That is the best way you should be running the software, because the people who run the software does not have to bother about the complexities of the source code. And that is very, very important, especially when you work inside a company, and especially when you are using microservices. There can be a lot of services that your company is developing: the front end, the back end one, the back end two, shopping cart, prime customer. There may be a lots of microservices that your company is developing, and all this software you want to install somewhere, right? Maybe multiple times you want to install in many places, and that's your job. So when you want to do that, you want to either double click, or you just run a single command. It should get installed, right? Without worrying about the software complexity underneath. So that is why, for every company, Whatever code your developers are developing in their laptop, the code need to be converted into some executable file, and that is very, very important. Okay, that is very, very important. Whatever code your developers are developing, it need to be converted into some form of executable file. And when I say executable file, it does not mean the exe file on Windows. That is one example of an executable file. There are various types of executable file depending on the technology that you are using, depending on various aspects. The kind of executable file that you want to create will change, right? Sometimes it could be an exe file. Sometimes it could be a jar file. So jar file, if you have Java installed, you can execute jar file on your laptop. Sometimes it could be a static website itself, a website that can be opened on a browser. So when I say executable file, please don't confuse yourself. Executable file, what I in my definition, what is an executable file? Any file that is easy to install, right? It could be an exe file, it could be a jar file, it could be a website, right? It could be anything, but not the source code, not the source code. Source code combined with everything else that software need, put together inside one single file, which I can simply execute and run the software. So that is what you can define an executable file or artifact. It's called artifact also. So artifact or executable file, what both means the same thing. So every company want to do this. Whatever source code that the company is developing, it should be converted into an executable code or an artifact. That is very, very important. And then it become easy for everyone else working inside your company. Great. And in order to do this process, there are various tools available. This does not have to be a manual process. Converting the source code and building an executable file does not have to be a manual process. There are various automated tools available, and that is what you will be doing most of the time. Every time you want to convert your source code into the executable code. So this is your source code. It consists of programs on a folder structure that can, all these softwares can be built into a single executable code that can be easily installed anywhere. So that is the process. So we will talk about what are the various steps involved in building a software to an executable file. So we'll talk about that. So let's talk about the build process, various steps. It all vary depending on the technology that you are using. So if you are using Java application, maybe you will be using different strategy. If you are using JavaScript application, so the steps can vary depending on the kind of technology that the company is using. So in our particular case, we have three various application. One is a front-end application developed in JavaScript, React. Another application, a backend one application developed in Java, another application backend two developed in Python. So we have three various applications that we are managing. So let's talk about them. So what are the various steps to build such kind of application? So right now, what you have is the source code of your software, right? This assume this is the front end software, and similarly, you have the backend one, the Java based software, and this one is a Python based software. So this is your front end software, and this is your Java application, and this is your Python application. So you have three different application that your company or that your developers are developing. And most of the time when developer develop the application, they don't develop everything themselves. They uses modules, libraries, and some external programs that are readily available rather than developing everything all by themselves. For example, you want to send out an email, or you want to compress or extract files, or you want to upload a file to the cloud, right? There may be various actions that a developer want to do while writing the code. And the good thing is that there are a lot of pre-existing code already available on the internet, wrote by experts. You can take that code and you can use them rather than writing all by yourself. And when needed, you can write them. So that's how the developers work. They uses a lot of dependency. They uses a lot of external programs while they develop the code. They don't develop everything all by themselves. They should not. They should be using the libraries or modules or whatever it is, the external program they should use every time they want to get achieve something. So when I say software, it simply does not mean source code. Source code means the code wrote by your developers. And then there would be other code that is available on the internet. Let's call them dependencies, right? There may be various dependencies that the code depends on. The front end will have a lot of dependency. The back end will have a lot of dependency, right? The various softwares will have various dependencies. So when I say software, it consists of the source code, whatever code my developer have written, whatever external code the developers are using, and maybe in this front end software there are some static files also, right? There are some images, images are there, style sheets are there, HTML, CSS, right? All these things are also there. So all these things need to be combined together to create the final executable file, right? So when I say software, it does not necessarily mean the source code. It means the source code plus the external programs plus the images, HTMLs or whatever. And then again, in order to run this, you need a machine and all. So there are a bunch of things that need to work together for running a software, right? And these dependencies, so your code depends on these many dependencies, and each of these dependency may depend on other dependencies also, right? The way how this ecosystem is working, every day your code will have some dependency, and each of those dependency may have other dependencies also. So this is the way how things works. So you want to make sure that all the dependencies are resolved. Maybe your code directly depends on some 10 dependency, but each of the 10 dependency may depend on other 10 dependency, and they might depend on other 5 dependencies. So that's how it works. So at the end, your code may depend on total 1,000 dependencies once you resolve all the transitive dependencies, right? So it's a highly complicated process of downloading the dependencies, finding out the transitive dependency, downloading them all, and then right, then combining the source code, the dependencies, then any other things that your software depends on, combining them all together and create one single executable file, the final executable file that your users can easily manage. So this is the process, right? Most of the time, the code and dependencies, it's the same story, whatever technology you use, whether it is a JavaScript application or whether it is a Java application, still you will have your source code and you will have your dependency. Your developer always uses dependency. So it's always there. It's not avoidable, right? Dependencies are always there, and all those dependency may depend on transitive dependency. So when I say the software, it means the source code, the dependency, transitive dependency, and everything combined together. And then finally you create one single file. Maybe you will compress them all together and create one single file. That is your executable file, and anyone can execute that file. And similarly for Python also, for every application, these are the common process that the application need to undergo before you can create an executable file from the application. So always remember, source code does not mean the entire software. Source code need to be combined with a lot of other things to form the final software. And then sometimes you want to compile the source code, right? Source code, some technology like Java. If you are using Java, then your code need to be compiled before you could build them. So there may be a number of things that you might want to do. So it all, there may be a multiple process that involved while creating the final executable file. So, but anyway, at any cost, that's what you want to do. You want to create a final executable file. You want to create a final executable file for the front end. You want to create a final executable file for the Java application, and similarly for the Python application. So this is what you want to do. Okay? This is what you want to do. So you finally want to create all these executable files. And now when I say front end, it's a website, right? It's a website. Technically, in our case, it's a website that has to run on a browser. So the executable file of the front end is nothing but a folder. It's a folder. Technically, it's a folder that can be opened on a browser. That's what it means. So that folder will consist of the source code, the dependencies, then it also consists of the HTML, CSS, images, whatever, right? So combining them together, you create a folder that every browser in the world understand. This folder may be opened in any browser, Google Chrome, Firefox, or whatever browser you have. You can just right click this folder and then open in a Chrome, and it should display a good looking website. That is the kind of executable file that you want to create for the front end application. That's nice. And then how about the backend application? When it comes to the backend applications, you want to create a executable file, because this application is not supposed to run on a browser. This application is supposed to run on some cloud server, right? So for that, what I need is, I need a exe file, jar file. Actually, jar is a Java executable file. Anyone in the world who has Java installed on a computer, that computer can execute this jar file. You might have used jar file when you want to install Adobe Reader or Adobe Flash Player in your laptop. You will be downloading a jar file, double click, click next, 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 and you must have Java installed in your laptop. If Java is not installed, you will get an error. It will ask you first you should install Java. So any computer that has Java installed, you can execute a jar file. And then for Python, right now, let's not worry about Python. We will talk about it later. Let's talk about the first two applications, the front end and the Java, and both of these applications need to be built into an executable file. And this is what my intention is. And this will be an automated process. And to enhance this automated process, every company uses various build tools. For the JavaScript based application, uh, npm is the build tool. And for Java based applications, it could be Maven, or it could be Gradle. There are various build tools available. And what these tools can do, they can automate this process rather than you having to take the source code, compile the code, download the dependency, combine them with the HTMLs, everything, and finally creating an executable file rather than a human doing it. These tools can do that process. You just have to tell the tool what it need to do. You want to tell the tool that first you should compile the code, then you should download the dependency, then you should download all the transitive dependency, then you combine them all together and finally create a jar file. So those instructions you will give to the tool by creating a file. You will write a file. Your developers will do this inside a file. They will write the instructions for a Java based application. The file would be pom.xml. For a JavaScript based application, the file will be package.json. So inside a file, your developers will write the instructions on how to build this code into an executable file. And then you would be using various build tools, and the build tools will read the instructions, whatever you have written inside the respective file. Maven will read this file pom.xml, and npm will read this file package.json to understand what are the instructions, what are the steps that it need to take until the source code is completely converted into a executable file. So technically, with a file that consists of the instructions and with a tool that is capable to read these instructions and do whatever is necessary action to create the executable file, then you can avoid a human's job over here. In this process, it can be automated, and this is how you should be doing. This process should be automated. Doesn't matter whatever technology that you're using, right? If for npm for javascript, maven for java, pip for python, then compose for php, bundler for ruby, whatever technology that your company uses, there are always a build tool available, and there is always a way your developer can give instructions to the build tool, so that the build tool know how to build this code into an executable code. So whatever technology that you uses, in our particular case, these are the three technologies that we are demonstrating, and these are the tools that we will take a look at, and we will be using these tools to build our software into executable code, and that's what we are going to do. And it is an automated process, it's not a manual process, and that's what we are going to do next, right? What we'll do next, we are going to build quite an application. We are going to build the quite friendly application. And as I told you, this is a website. So what you need is a folder that consists of the entire website, HTML, CSS, JavaScript code, everything put together inside one single folder. And this folder, the browsers should be able to understand. Every browser in the world should be capable to understand this folder. They should be able to open this folder in a browser, and it should display a good looking website. That's the kind of folder you want, right? As a result of the build process, when you build your front end application, what you finally want is a folder that may be opened in a browser, right? Or in other words, a browser can execute this folder, right? So this is the kind of thing that you want to create. So you want to create a folder. Let's call the folder name build. That's the folder we are going to build. So let's talk about that. So let's talk about the front end application. For now, you forget about other applications. So it consists of the source code. So let me show you the code once again. It consists of the CoIT frontend folder. This is the CoIT frontend folder, and inside that there is different JavaScript programs. There is HTML file. There is images, and there are things like that. And let it be. And then there is also a file called package.json, and inside the package.json, you can mention what is the version of your software that you are building, and then you can also mention what are the dependencies the code depends on. Your developers would write it down. Most of the time developers would auto generate them. So basically, these are the external programs that your program depends on, right? Material UI, React DOM, React scripts, prop types. These are the dependency. Whoever my developer is, when he developed my front end application, he is using these many dependencies, right? These many external dependencies. These are not programs that my developer wrote. These are external programs that my application depends on. And every developer do this. I already told you, they use a lot of dependencies when they develop something. So all this dependency needs to be downloaded. And then every this dependency will have transitive dependency, right? I already told you, your code depends on 5 dependencies total. Maybe each of these 5 dependencies may depend on 20 other dependencies each. And they might depend on some other dependencies. So at the end, when you resolve all the dependencies, it would be, 100 or 1000 dependency may be there total. And then some script, what is the exact. So when you run the command npm build, npm start, what is the exact command that has to get executed. Again, this file is prepared by your developer, so you don't have to worry too much about this particular file. Your developers prepare them. So just ignore that. So what you need to understand is that this file is understood by npm, a build tool that you use for building the JavaScript project or not project. So that's what we are going to do. I'm going to build this CoIT front-end application to a build folder using npm. npm is the build tool, whatever I'm going to use, right? And I can do it on any computer. It could be on my laptop if I want to convert the source code into executable code. Now, if I have npm installed on my laptop, I can do this, right? Or maybe I can do it on a machine in my AWS account, and in real time it happens in both places. It happens in developer laptop, it happens in the cloud, it happens in various places. So today what I will do is I'll create a machine in my AWS account, and inside that machine I will do the build process. But yes, the same process can be done by a developer on his laptop. Same process can be done on a server in the cloud. The only criteria is that npm should be installed. Whichever machine you want to convert the source code to executable code, you should have npm installed. That's the only criteria. As long as that criteria is met, any machine in the world can build your application. So today I'm not going to use my laptop. I will create a machine in my AWS, and in that machine I will get the code, right? Whatever code that you see on my laptop, the same code I will copy to a machine in my AWS account. Then after that I would be working on that machine. You can also do the same. So let me create a machine in my AWS account, because that is where i'm going to I'm going to do the building, right? So you can also do the same. Or you can install npm directly in your laptop, and you can do the building in your laptop, right? A developer does that, but you generally do the process in the cloud as a DevOps engineer. But let's, we will get into the roles and responsibilities later, right? Right now you don't worry too much about the roles and responsibilities of developers and DevOps engineers and things like that, right? Let's not make it too much complicated for now, but we will be discussing that in detail later on. For now, I so I have a machine in my AWS. I created this machine. I called it build, and this is the IP address of the machine. So the plan is that it is inside this machine. I'm going to do all the process, right? So I'm going to log into the machine first, and into this machine I have to download the code first. First of all, let me log into the machine from my laptop. That is done. And let me run this command to become the root user. That is the first thing that you do. Now the next thing, I want to copy the code from my developer laptop to this AWS machine. So, and in order to do that, this code is already available in the GitHub. Not only you, anyone in the world can get this code. I'm going to send you this link to you. And you can follow these instructions. You can go to this particular URL and click on this green color button, and then click on HTTPS over here, and then you can copy this URL. And using this URL you can download the code to your laptop or anywhere in the world. It's anyone in the world can use this URL to download the code. This is a GitHub URL. So what I'll do is I'll go to my AWS machines command line, and I'm going to run this command. The command is git clone followed by the URL. So as soon as you run this command, what happens is the entire code will be downloaded to that machine, and you type the ls command, you can see the code over there. So if you go to that particular folder, you can see the CoIT frontend folder. It consists of the HTML file and the JavaScript code and everything. Then CoIT backend 1 folder, CoIT backend 2 folder. Everything is now available inside your AWS machine. Whatever was available in my laptop earlier, all these folders were in my laptop. The same folders I copied to an AWS machine, a Linux machine, and then I can use the ls command to see them. All the folders are there, and if I go to the CoIT frontend folder and then type the ls command, I can see the src folder. I can see the package.json file, right? Whatever my developer had in their laptop. The same thing now I can see them inside my AWS machine. So what I'm going to do is I am inside the CoIT frontend folder, and from this folder, if I want to build it, I can use the command npm install. npm install, and another command is npm run build. These are the two commands that I can execute from the CoIT frontend folder. That you make sure that you execute the command from the CoIT frontend folder, npm install and npm run build. These two commands, if you execute from the CoIT frontend folder, what npm install command does is npm install command will read the package.json file, try to understand all the dependency, download all the dependency, transitive dependency, everything it will download and put it locally inside a folder. That's what npm install command will do. The next command is npm run build. What npm run build command does is it will take those dependency downloaded by the npm install. It will take the source code. It will combine the HTML, CSS, everything together. It would create the final build folder. That's what this command will do. So these are the two commands you can simply execute, and then you will get an executable file. That's the only effort you need to take. I already told you there is no human effort. You don't have to download dependency. Don't have to worry about creating the final folder. NPM is an automated tool that will do that. So all you need is a computer. All you need is a computer. It could be a cloud server or it could be a laptop. The computer must have npm installed. So first of all, I should install npm. Npm is currently not installed right now. If I try to run the command npm, I will get an error. It would tell me npm is currently not installed inside the aws machine. So I want to install npm inside the aws machine. Inside the aws machine, it's ubuntu. So the command is, if you want to install something on ubuntu, the command is, first you will run apt-get update, and then you will run apt-get install, followed by whatever package that you want to install. So in my case, I want to install npm. And in ubuntu, this is how you install softwares. Something I didn't tell you. This is how, if you want to install any software in ubuntu, the command is apt-get update, followed by apt-get install, followed by the name of the package. If you don't know what package, right, search in Google. Let's say you want to install npm, you will search in Google npm ubuntu package, right? If somebody want to install npm on ubuntu, what is the package name that they should install? Just confirm, right? It's npm itself. Most of the time it's the software name itself, but just confirm by searching in Google. This is how you can search in Google. First search result itself will tell you what is the package name. Package name is npm install. So that is the name you have to put over here along with the apt-get install. So first I have to run the command apt-get update. And once the apt-get update command is complete, it's a good practice. First you run the apt-get update before you run any apt-get install. Apt-get install is what you use when you want to install any software in Ubuntu. You use apt-get install. So yeah, in my case, that's what I'll do. Apt-get install npm. Run this command, and then apt-get would tell you, I'm going to install npm, not just the npm, but every dependencies of npm as well. Do you want to continue? So type Y for yes and just press enter, and that's it. npm will get installed inside your AWS machine. So not only npm, we may want to install Maven, we may want to install Python pip, we may want to install various software. Whenever we do any installation on Ubuntu, we will be using the same set of commands. Apt-get update followed by apt-get install. So why did I install npm? Because I need npm, right? The computer that want to build the CoIT frontend, that must have npm install, whether it is laptop or AWS machine, whichever machine you want to run the build. The first thing that you have to do is the machine should have npm install. So currently, that is, I am in that particular process. npm is being installed. Once npm is installed inside your AWS machine, your AWS machine is ready to run the npm install command and npm run build command. These two commands your AWS machine can now run. First of all, npm should be installed. That's what going on right now. Once npm is installed, you can execute these two commands from your CoIT frontend folder. And the first command, the npm install command, will read the package.json file. That is the default file. You don't have to specify the file name anywhere. By default, npm will always look for this file. So it will read this file. It will read the list of dependency. download them, download the transitive dependency, everything it will download to some local folder within the machine. After that, it execute the npm run build command. What this command does is it will take those dependency downloaded by npm install. It will take the source code. It will take the HTML, CSS, and other things, and then combine them all together to create one final folder that can be opened on a browser. This is what we will do. So let's see what is the status. So first npm should be installed. We are still waiting for an npm install to finish. As soon as npm installation is done, now we can go to the CoIT frontend folder and run the npm install and npm run build. So let's wait. Okay, guys, so npm is successfully installed, and you can try running the npm command. It is giving you some output. It looks like npm is successfully installed, and once npm is installed, it's time to run the command npm install, then npm run build. So I don't have to mention the package.json or anything. By default, when I execute this command, I'm going to execute this command. It automatically read the package.json, read the dependency list, download all the dependency, all the transitive dependency, and put them together inside some local folder. That's what npm install command will do. So I just started the command. Now npm is reading this package.json. It is trying to download everything, dependencies, the transitive dependency, everything. It is now trying to download. So let's wait until the whole process is completed. It won't take too much time. Within few minutes, or if not seconds, all the dependency will be downloaded by npm. Right? Remember, if you have to do it manually, a human has to do this manually, understanding the dependency, figuring out what are the transitive dependency, downloading them, finding out their dependency. If you want to install them all or download them all manually, it's like a week's job, right? There may be hundreds of them. So this would simplify the process. npm automatically figure out the dependencies from the package.json. Then it checks the dependency, and using some online methods, it will figure out what are the dependencies of the dependency, go to them. Then online it will verify what they depend on, right? Everything it will verify online, try to understand the dependency, download everything, right? Download everything on a local folder that it will create now. So I'm just waiting for that. Now you can see actually it's almost 1177 packages that got downloaded. It's not right. In the package.json it was 5, but total it was huge. And then what happened is, all of them got downloaded and they are added into this particular folder called node modules. Node modules temporarily got created just now when I executed the npm install command, and it consists of all the dependencies. Perfect. So you are done with the npm install command, and I told you there are two commands that you need to run. Npm install command will simply download the dependency. It's the npm run build command that would create this final production build. So that is what I'm going to run next. Npm run build. Make sure that you run these commands, both npm install and npm run build. Make sure that you run these commands from the same folder. So this command will take those downloaded dependency, take the source code, HTML, CSS, everything, combine them together to create one build folder that you can run, that you can open on a browser. So just run this command. And it's creating the final optimized production build, or technically it's a folder. It's going to create a folder, and this folder may be opened on any browser in the world, Google Chrome, Firefox, or whatever folder it is. So just it's done. Now you type the ls command, you can see a folder called build, right? A folder got created called build. This is your final build folder, and I'm not going to open it inside any browser for the time being. I will explain it later. But yeah, I have successfully created the executable folder, and this folder I know it's ready to run on a browser. You can open this index.html, copy the entire folder to your laptop, then open this file in your browser, you can actually see a good looking website, right? That's what you will see, but I'm not showing you now. I will show you that later, right? But yeah, my intention was that I wanted to build the final build folder, and yes, it is ready, and it is now inside my AWS machine within the CoIT frontend folder. Inside the CoIT frontend folder, a build folder is now ready, and I will show you that folder later, right? I mean, let's for now let's not worry. Our frontend project is ready, right? Our executable file is ready, and any browser in the world can open this folder, and it can display a good looking website. Now let's go to the backend application. That's what we are going to talk next. Let's build our Java application. So right now we are looking at the front end application. Now let's take a look at the Java application, and it consists of a pom.xml file, which consists of the instructions on how to build the Java application into a jar file. It's a jar executable file. Any computer that has Java installed can run the jar file. But our intention is we want to create the jar file. Later we will run the jar file. Our intention is not running the jar file. So this is what we want to do next. And in order to do that, we are going to use a tool called Maven. So Maven should be installed on the computer where you want to run it. So this is what I'm going to do next. Let's build our Java application to a jar file. Let's do that. So that's what we are going to do next. So again, I'm going to do that inside the AWS machine. So the only criteria is that the machine must have Maven installed. So yes, it's an Ubuntu server. I will use apt-get install to install Maven. So I go to the server and I'm going to run the command apt-get install, apt-get update first, and then you can run apt-get install. It's a good practice to run apt-get update before you do any installation. Sorry. Apt-get install followed by, I hope it's Maven, but yeah, I always search in Google to confirm, right? I always search in Google Maven Ubuntu package. What is the Ubuntu package for Maven? If it is Maven itself, perfect. Yeah, it's Maven itself. But yeah, always confirm, right? Once, because it can be different, right? It can be different. Package name and software name can be different. So always search in Google to confirm. So it's Maven itself. In my particular case, it's Maven itself. So let's go ahead and install Maven. apt-get install Maven will install Maven. Do you want to continue? Yes. Press enter, and then Maven will get installed. And once Maven is installed, what I have to do is I have to go to the respective folder. In this particular case, the folder is CoIT backend one, right? That is the Java application. CoIT backend one. I go to the CoIT backend one folder, and inside the folder, I will run the command maven install, mvn install. Mvn install is the command I have to execute. Then what this particular command does is it will first look for the pom.xml. You don't know how to mention the file name pom.xml. It automatically look for the file pom.xml, and it will locate the file pom.xml. And inside the file, it consists of clear instructions. Let me show you that pom.xml file. I will show that in my laptop, which is more graphical and easy to understand. Same file is there in the server also. And I mentioned what is the executable file that I want to create, what is the version, and I want to create a jar file, and then what are the dependencies, right? These are various dependencies that my code depends on. So this is a XML file, not a JSON file. XMLs are a bit complicated to read, not very, but yeah, it's not as easy as package.json, right? But doesn't matter. So this file consists of all the instructions to build the Java application to a final jar file, and this is going to be the name of the jar file, sentiment analysis web 002 snapshot dot jar. That's going to be the final name of the jar file that I am creating. The jar file is a jar executable file. Any computer that has Java installed can execute the jar file. So once Maven is installed on my computer, I can just run the command maven install, which will read the pom.xml file, do all the instructions necessary, and finally create a jar file. That's what maven install command will do. So let's go to the AWS machine. Right now you are inside the AWS machine, and inside the AWS machine I'm going to run the command maven install. Okay, I am in the wrong folder. First I have to go to the folder CoIT backend 1. CoIT backend 1 folder I have to go into, and it has the pom.xml file. It consists of the instructions. There is an src folder, and inside the src folder I have various Java programs available and everything. So basically my intention is that this whole project I want to build into a jar file. The command is maven install. Mvn is the command. Maven install is the command. I run this command. It will first check this file, look for the file pom.xml, which in my case it's already there. Pom.xml file is already there, and it also consists of the instructions. So maven install command will read this file, follow the instructions, and finally create a jar file. So just run this command and wait and relax, right? You don't need any human to do this. Just run this command, and this command will compile your code, source code. For Java, code need to be compiled. So it will compile the source code, it will download the dependency, then finally it will combine the source code and the dependency together and create a compressed file, that is the jar file. So a single maven install command will do all the job, that whatever is necessary in the background to create your final executable file. So I just run the command, sit and relax. Within few minutes or seconds your jar file will be ready. So that's what maven install command will do. Okay guys, it's done. The process is done, and now the jar file is ready. All right. So now you type the ls command, and you can see there's a new folder that got created called target. And if you go inside the target folder, you can see a jar file, sentiment analysis web 002 snapshot dot jar. This is the final jar file, and this jar file can be executed on any computer, right? Anyone who want to run the backend software, you can just execute this jar file. The only criteria is that Java should be installed. Any machine that has Java installed, you can execute this jar file. And again, I'm not executing that yet, right? Just wait, right? Wait for a while, and we will do that later. Great. So now we have successfully built our backend one, the Java application, into a executable file, artifact, whatever you want to call it. It's a jar file. Great. So now we have successfully built the Java application and also the front end application. Now the next thing, we want to run the application, run the applications. So basically, running the application generally means you want to run those software on a computer. That's what it means, right? Simply running the application generally mean, now you have developed the softwares, you are a developer developed them in their laptop by writing the code. Now you have built the software into some executable file. Now just execute those files, right? Execute the files, and then the application will start running inside a computer, and it can run on any computer in the world, right? The only criteria is that if it is a Python application, you should have Python installed before you run the Python program. If it is the jar file, you should have Java installed. If it is the build folder, you should have a browser, right? That's the only criteria. As long as the criteria are met, anyone in the world on any computer, they can run these applications, right? That's what mean by running the application. You are actually starting your applications inside a machine. It could be a machine, it could be a laptop, it could be a machine in the cloud, it could be any machine in the world. As long as the machine have all the necessary environments ready, then the machine can run your application, right? So we are going to run the application and we are going to start with the Python application. And as you might have already noticed, I'm not building the Python application to an executable file. The reason why I didn't do that, actually, technically, it is possible. Python has what's that? Okay. There is some software that you can use to build Python project into executables. But in my case, I'm not doing that because in my case, it's a very simple software. The Python application consists of one single Python program. So when I say executing the software, I mean executing this program. So to execute this program, I don't need a build. All I need is Python installed, and then I can just execute this program that will do the job. And that is why for the backend to application or the Python application, I did not do any build stage. I did not create any executable code because I can simply execute that Python program. It's a simple application. That's why I did not do that. So building is not necessary. Building is necessary if you have more than one program, or if your application is complicated, building is necessary. Otherwise, building is not necessary. If it is a simple Python program, you can just execute that single program using Python. That's enough. So that's the point. So that's why I didn't build the Python application. So that's the reason. So don't get confused why I build both front end and back end one, but not Python. This is the reason. So let's run the application and we will start with the Python application. Run the Python application. That's the first application that I'm going to run inside the machine. So I'll use the same AWS machine. I already have an AWS machine, and inside the AWS machine, I'm going to run the Python application. So I start from the Python application. Okay, let's do that, right? So let's run the Python application. So I'll start running the Python application, and there are few things that I have to do first before I could run the Python application. I have a Python program, right? So this is the assume this is the Python application. Forget about all these jar files, build tools, stuff like that. So right now what I have is I have a machine, a AWS machine, and it consists of a folder backend two. There is no build. I didn't create any build. There's a folder called CoIT backend two. Inside that folder, there is another folder called SA. Inside that folder, I have my Python program, right? I have my Python program.py or whatever, right? So that is the current situation. So inside my AWS machine. Okay, sorry, I got disconnected. Let me log in again. Okay, guys. So what I have is right now I'm inside the CoIT backend 2 folder within my AWS machine, and it consists of an SA folder. And inside the SA folder, I have a Python program, and I can simply execute this Python program. That's all I want, right? It's as simple as that. I just want to execute this Python program, and you can use this command Python 3 space, then the name of the Python program. This will do. This is the command I can use in order to execute a Python program. Before that, you should make sure that Python is installed. On AWS, Python is installed by default. That's why I'm not installing it again. So the command is Python 3 space, then the name of the program that you want to execute. So run this command and the program get executed. But right now I try to execute it, I will get an error. I'll get an error because there are some dependencies that I have to install. So this program has some dependency. If I open this file, this program depends on Flask request JSONify. So there are few dependencies that this program depends on. And actually, fortunately, my developer have put listed all those dependencies in a separate file called requirements.txt within the same folder. Take a look at that particular file content. And these are various dependencies. There are 4 dependencies that my Python program depends on. So first I should install all these dependencies inside inside this machine before I could execute this Python program. Right now, you try to execute it, you would get an error. You would get an error because dependencies are not installed. So let me install the dependencies first. In order to install the dependency, I can use this command python3 space by install space minus r requirement.txt. So what this command does is it will read the file requirement.txt. It will understand what are the various Python modules to be installed. Then it will install each of those modules one by one. All the 4 modules get installed. That's what pip3 install command will do. So what is pip? Pip is a Python dependency manager. If you want to install any Python dependency, Python module you want to install or uninstall, or you want to upgrade, you can use pip3. Pip3 is a tool that Python developers uses when they want to install a Python module or uninstall a Python module, right? Pip3 is the tool. But pip3 is currently not installed, I think. Let me try to run this command. The command will fail because presently pip3 is not installed. So first I should install pip3. This is the command that I can execute to install pip3, right? Python 3 pip. This is the package to be installed. So first let me install pip apt-get install pip3 python 3 pip. So run this command. So this command will install pip3 because first pip3 should be installed before I could execute this command. So that's what I'm doing. I'm just installing pip3. It's being installed, and once it is installed, now I will be capable to this is frustrating. Yeah, it's done. So it's installed. Now the next thing I am ready to run this command pip3 install minus r requirement.txt. So previously pip3 was not installed. Now I installed it, and now I'm just trying to run this command. It will read this file requirement.txt, and all the modules whatever you mentioned in this file, your developer does that. Your developer, when they develop the code, they will also create a requirement.txt file, and inside that file they will list down the dependencies. Then pip3 can automatically read that file and install all the dependency without any human effort. So just run this command and you will notice that pip3 is installing all the dependencies whatever you mentioned inside the file, and it says successfully installed all these things. Perfect. So it's done. Now I think you can now try to execute the Python program. This time it should work, right? So this is the Python program that I want to execute. Let me try to execute this program. Now let's see if it will work or not. The command is python3 space, then the sentiment analysis.py. So this is the program name. Let's try to run this command. Last time I tried to run it, I was getting some error because dependencies were not installed. Now I install the dependencies. Let's try to run this command. Looks like it's working. It's telling me it's running on the port number 5000. The Python program got started, and probably as per the logic whatever my developer have written inside the program, the developer wrote the program in such a way that whenever somebody execute this program, it will start listening on a port number 5000. So this is the Python program. There is some programming logic that my developer have written over here, which would actually uh, you know ask the program to listen on the port number 5000. So that's what it is doing right now. And let's not worry too much about the programming logic. It's not important for you as a DevOps engineer. But yeah, the most important part is I did not get any error. I successfully started the Python application without any error. It's working, right? That's the most important part. Awesome. And I also got a new information that the program is listening on the port number 5000. So I can speak to this program by speaking to the port number 5000. What is a port? A port in Linux is logical connections that you can establish to your application that is running inside the Linux. So in my particular case, I have a Python program. It is exposing itself to a port number 5000. Then somebody else talk to the port number 5000. They can actually speak to the Python program directly using a port number, using some HTTP call. We will talk about that later. But yeah, right now we have successfully executed this command. This is the command which will run your Python application. And yes, it is running and it is giving me some, success message. Looks great. So your Python application is running. And to summarize, if you want to run the Python application, there are few criteria that you need to meet. First of all, you should install all the dependency that your Python program need. And second of all, Python itself should be installed, right? On any computer that want to run the Python program, first Python 3 should be installed. In my case, it's AWS machine. Python 3 was already there. So the Python 3 is there. Dependencies were not there. So what I did is using pip3, I installed the dependency. Pip3 was not there. I installed pip3 also first. Then using pip3, I install all the dependency. Then I executed the program. The command was Python 3 space program name. So, that is how those are the three steps that I should take care before I am ready to run the Python applications. So now Python application is running. It is listening on port number 5000. Now the next thing, I want to run my Java application. So now let's run the Java application. And again, Java application can run on any computer which has Java installed, right? So all you need is the jar file. You can double click the jar file or you can execute a single command if you are using Linux. No, the only criteria is that Java should be installed. So this jar file can be given to anyone. It could be your engineers, it could be a machine in the cloud, right? Wherever you want to run this jar file, you can run it. So in my particular case, I'm going to use my AWS machine, which already has Java installed in it. Did I install Java? No, actually, when I installed Maven, Java got installed automatically. So you don't have to install Java now. If you are using the same AWS machine, it will already have Java installed in it, because when you install Maven, automatically Java get installed. You don't have to do it explicitly. But if you are trying to run the jar file on a different machine, your laptop or some other machine in the cloud, first you should install Java and then you should copy the jar file and then you can execute the jar file. So I have my Java application and basically I have my jar file. Technically what I do have is the jar file. I have already created the jar file. I already have created the jar file and the jar file is I want jar file to be inside this machine. Then apart from that, the machine should have Java installed. So as long as these two criteria are met, you can execute the command Java minus jar, then the name of the jar file. This command I can execute. Then it is Ubuntu, so I have to execute a command. I cannot double click, there is no mouse. So this is the command that you have to use in order to execute the jar file, or in other words, start the application. So that's what I'm going to do next. So let's do that. Let's do that. First, I will go to my AWS machine. This is I'm going to log into my AWS machine. I already have the jar file, which is available in the same machine within the CoIT backend 1 folder. Within the target folder, I already have the jar file in it. So this is my jar file. So I want to execute the jar file. The command is Java space minus jar space, then the jar file. So on Ubuntu or any Linux or even Windows also, if you are executing from the command line, if you want to execute a jar file on Linux or from a command line, this is the command Java space minus jar space, then the name of the jar file. So what this command does is it will execute the jar file, and as a result, our backend 1 application will start. That's what I want. That's what I want to do. So just run this command. And I am expecting some error here. I'm intentionally trying to execute this command. just to see that error. So it is telling me there's an error. There's an error creating, could not resolve the placeholder via the value. So it is just trying to get this particular variable which I did not provide. I did not provide this variable. It is looking for this variable, and it is nothing but the URL of my Python application. The way how my application is developed is the Java application want to speak to the Python application, and it want to send some data to the Python application, and it want to get some response from the Python applications. And I will tell you the workflow later, but right now the only thing what you need to understand is that when I developed this application, Python is developed as a separate microservice, Java is developed as a separate microservice, but they are not completely independent. Java application want to talk to the Python application, send some data, get some response. All these things need to happen. And in order to do that, my developer configured the Java application in such a way that every time you run the Java application, you can set this variable and point that variable to the URL of Python. So Java application want to know the URL of Python because when Java application run, it want to speak to the Python application. So Java application need to know the URL of Python. You should provide that information at the time of running the Java application. And this is how you do it. This is the command that you use to run the Java application. Last time I ran it, it failed because I did not provide this variable. This time I am providing the variable SA logic API URL, and the URL is HTTP localhost 5000. So what I am doing here right now is, yes, you already know I'm executing the jar file. Of course, I'm trying to start my Java application. That's what I'm trying to do. And at the same time, I also want to pass some information to my Java application. I want to tell my Java application, hey, this is the Python URL. You want to speak to the Python application. This is the URL that you can speak to. I am passing that information also as an argument while executing the jar file or while executing the backend application. So 5000, I already know my Python application listen on port number 5000, and then it should be IP address colon 5000, but in my particular case, it's the same machine. That's why I call it localhost. When you have two application running on the same machine, in my particular case, same AWS machine, I first executed Python. Sorry. Now I am running Java. So both are running on the same machine. On the same machine, two applications are running. They can talk to each other using the name localhost. You don't have to remember the IP address or anything. You can use the name localhost. So this is the idea. So I just run this command, and let's see, this time my Java application will get started. Not only it will get started, it also become aware of the URL of Python, or now my Java application is running, and also it know how to speak to the Python application because my application need such. I will tell you how my application work later, but for now, my Java application is not completely independent of the Python application. Technically, my Java application want to speak to Python application, so it definitely need to know the URL of Python. And then I already know Python URL is 5000 port number, and the IP address of the Python machine, I put it localhost because in the same machine, same AWS machine. That's why I put localhost. If Python was running on a different machine, I would be using the IP address of that machine instead of localhost. But right now, Python is running on the same machine as Java. So then in that case, instead of IP address, you can use the localhost. So this is the Python URL, and every time Java want to speak to Python, it will speak to that URL, and I am making my Java application aware of that URL. So that's what I did. My Java application is running successfully, and also it know how to speak to Python. And I will explain when it will speak to Python or how it will speak to Python. That we never discussed. But yeah, just uh, it does speak to Python, and for that it need to know the URL of Python. So I provided that information when I executed the Java application. So that's the current status. I executed the Python application. I started the Python application. I also started the Java application. So two applications are currently running inside my AWS machine. And now one more application is left to be started. That is nothing but the front end application that we will see tomorrow. So um, that's the point, right? All right. So let's talk about how to run the front end application. The front end application means, and I mean, it has to run on a browser. In the last session, we have already built the front end application. We created the build folder using npm install and npm run build command. We have created a build folder, and that build folder is ready to be served to the people. And currently that build folder is located inside an AWS machine. All our experiments we have been doing inside an AWS machine. So inside that machine, you will be able to find the build folder, and that build folder you want to open, right? And who will open it? It would be a browser, right? The build folder is executed by a browser. A browser want to open it, and then a browser is capable to display the HTML style sheets, images, and even execute those JavaScript programs, whatever is written inside the front end. So, basically, technically, this is a web application, and it's a website that I want to serve to all my customers. And yes, as you expected, it is not very practical that you give the copy the build folder and give it to every customer and ask them to open it in their browser, right? It's not the right way to do. So what you need is a web server. What you need is a web server software to be installed inside your AWS machine or any machine where you want to run the front end application. So, technically, I will tell you what exactly do you need, right? Or think about how Google works, right? How Google.com works. You on your laptop, you browse for Google.com, and then your laptop connects to some machine on the internet. It could be a machine in AWS, Google Cloud, or whatever, right? I mean, your browser speak to that machine, and that machine will respond to the browser with the web page, right? And that is when you see Google.com. Understood? So that way, so you now you think about this, right? I mean, this is what you want your customers to do. Your customers all over the world, they want to open the build folder in their browser for sure. Yes, they want to do that, but that is not manual process. That is has to be an automated process. Your customer should be browsing for a URL, and their browser will be speaking to some machine. Assume your AWS machine, and this AWS machine is capable to serve the build folder to the browsers, right? Assume that is what this machine is capable to do. So this is how I want to run my front end application. I don't want to run the front end application on the server. Instead, I want to install some web server software. I will tell you what is a web server software. Basically, I want to install a web server such as Apache or Nginx. I have to install one of this web server software inside this machine, and I want to configure those web server software to serve this build folder, the CoIT front-end application created as a website folder, and I want that folder to be served to the people all over the world by a web server, and this is what I want to do. And if I do that, then people all over the world can browse. Maybe they can browse for the public IP of the AWS machine. Whatever AWS machine that you created in the cloud, it has a public IP. What that means is it is reachable from all over the world, and anyone in the world using their browser, they can browse for the URL HTTP public IP. I mean, right, public IP of your AWS machine. And since this is URL is public, right? Since it is a public IP, anyone in the world can browse for this URL, and whoever browse this URL, their browser will connect to the AWS machine. And then Assume you configured a web server software inside the AWS machine to send this build folder to them, right? Build folder to people. Assume if you did that, right? Assume if you did that, then things would be much easier, and you would be able to serve the build folder to people, right? That's the overall idea. Great. So the next thing, what what we want to do is, mm, yeah. This is what we want to do. We want to set up a web server inside our AWS machine. We will use the same AWS machine. If you want to use a different AWS machine, it's up to you, right? You can always create a new machine, copy the build folder into the new machine, and then set up a web server and everything in the new machine. It's up to you. But today, I'm going to use the same machine where we have been working. I'm going to log into the machine and I'm going to install the web server software. Apache I will use for now. Later we will also see Nginx, and I will install Apache. Then after installing Apache, I will tell Apache that, hey, you listen on port number 80. That's what Apache do. Apache listen on port number 80, and any browser who talks to the port 80, yes, browser speak to port 80 by default. That is the default port number of HTTP. And when that happens, the Apache will see that connection coming from the browser. Apache will be serving this build folder to the people, and that's what Apache will do. So that's what I'm going to do. I'm going to install Apache inside the AWS machine, and whatever build folder we created in the last session, we will configure Apache to serve that folder to people, right? So that's what I'm going to do next, right? So let's talk about that. So what I'm going to do next. So we are going to use Apache. There are many web surveys available. Apache and Nginx, various web surveys. They are free. They are open source. Anyone in the world can install it. And then that's what I'm going to do. I'm going to install Apache inside my AWS machine. So I will log into my AWS machine first. And then after that, I will set up the machine. I will install Apache inside the machine. And then that is a web server software which I am installing. And this software is special. It is capable to listen to the browsers who connect to your AWS machine on port number 80. So I am inside the AWS machine, and I'm going to do this. First, I will run the apt-get update command, and then I will run the apt-get install command. So I want to install Apache. First, I will search in Google. I don't know what is the Ubuntu package. I always search in Google first before deciding what package name. So it's Apache 2, right? I told you sometimes the software name and package name can be different. In case of software, it's Apache, but the package name is Apache 2. So always search in Google to confirm. You can get that information from directly by going to this website also, packages.ubuntu.com. But yeah, Google search would give you the correct result in the first page itself. So that's what I'm going to do. I'm going to install Apache inside my AWS machine. So that's the process that is currently happening, and Apache is now being installed. So what is Apache? Apache is a web server software that I am currently installing inside my AWS machine. And what this web server software is capable of, once you started the Apache service, it will listen on port number 80. Now any browser all over the world can talk to this machine on port 80, and then Apache is a software. You can assume Apache to be a software running inside the machine. It can see if any browser connects to port 80, and then it can do what you ask it to do. So that's what I'm going to do next. After installing Apache, I want to tell Apache to serve the build folder to people, right? Anybody who requested for anybody who connect on port 80 of this web server, this is the folder that you want to serve to them. And in order to do that, you have to copy the build folder to the Apache folder, www html. This is the document root of Apache by default. By default, this is the folder Apache will be serving to the people. So right now the build folder is sitting somewhere else. I will copy that build folder to this folder. This is the Apache document root by default. So once I did that, from now the build folder content would be there in Apache. Then Apache would be serving that content to the people whoever is browsing. So anyone who is browsing, now they will see the front-end application in their browser. So that is exactly what I want to do. I want to install Apache. I already have. Now I want to tell Apache, hey, serve the build folder content to people. And how do I do that? I copy the content of the build folder to the www HTML, and let me do that. So Apache is installed and I'm going to start Apache. Apache service need to be started. After installing, the command is service space Apache to space start. This is the command that you use to start any service in Linux. In my particular case, I started Apache. Now, where is my build folder? My build folder is here. Yesterday in the last session, we created the build folder, and this is the one, the build folder over here. I want to copy the whole content of the build folder to the www HTML. So before that, first of all, let me go to the www HTML, and it contains some sample file. I'm going to delete it by default. It would contain some content. I deleted that file. I don't need anything inside the www HTML, but the build folder. So that's what I'm going to do. I'm going to copy the build folder, cp -r. If you want to recursively copy including the folder, the command is -r, cp -r /root CoIT frontend, and the build. So this is the folder. I don't want to copy the entire folder. I want to copy the content of the folder. So /* means everything which come under the build folder. So I'm copying the build folder content, every content of the build folder I'm copying to what is the destination? www HTML. You already know the cp command, right? Cp command will copy everything from source to the destination. So once you executed this command, now I am inside www HTML and all the build folder content has come here. So it's done. It's done. So what you did is you installed Apache. After installing Apache, you copy the build folder to the Apache root folder, which is www HTML. Now Apache is ready to serve the files to the people. Whoever is requesting, Apache is ready to serve this website to the people. So let's see that. But before doing that, there are certain other things also that you need to do. Technically, I will tell you what needs to be done. Now everything is ready. All configurations are done from the Apache side. Now anyone in the world ever speak to port 80 of your AWS machine using their browser, they will see the front-end application. Apache will be serving the front-end application to them. So this is what the current situation is. But there is one problem actually. When people try to connect to port 80, AWS don't allow them to talk to port 80. AWS block port 80 by default. So you should allow port number 80. You want to tell AWS, hey, please allow all connections coming to this machine on 80. I want 80 port to be public. So AWS has some security settings that stops people to talk to port 80 of the AWS machine. I'm going to change that settings now, right? So that people all over the world now can start speaking to port 80 of your AWS machine. So let me make some adjustment on the AWS side. So I'm going to open port 80 in AWS security group. So in my particular case, I'm using an AWS machine. That is why this practice applies, right? So port 80 should be acceptable. The people of all over the world should have the ability to speak to port 80 of your AWS machine, but AWS don't allow you to do that because AWS by default, they have some security settings that would prevent you from doing that. And I'm going to change that settings. I go to the browser and I select the machine by checking the search checkbox here. And then over here, there is something called security. You can make a note. This is something that you have to do. Click on security. And then over here, you can find something called security groups. Click on the security groups name, whatever name that you see. It's a clickable link. Click there, and then you have the ability to click on inbound rules. By default, it is inbound rules, but yeah, click on it anyway to make sure. And then there is some rules. You will see the inbound rules over here, and that's what I'm going to do. I'm going to create a new inbound rule to allow port number 80. So for that, click this button, edit inbound rule, and then add rule. Then over here you select HTTP from the drop down. So from the drop down, you simply choose HTTP. Port 80 will appear automatically here. And then whom I want to allow? I want to allow anyone in the world. So you choose anywhere IPv4. Anyone in the world have the ability to speak to port 80. So that is what this particular rule means. Allow HTTP on port 80 from anywhere in the world. Anyone in the world have the ability to connect to port 80 of my AWS machine. That is what it means. Just click on save button, and now from now AWS will not stop your customers, right? You allowed port 80 onto your AWS machine, so people all over the world, they can talk to your AWS machine. And how do they do that? How your customers talk to your AWS machine on port 80? They browse for the public IP of your AWS machine. Or if you have a registered website, you can point your website to this IP, and they can browse for your registered website. For today, for our learning, we are going to browse for the public IP of the AWS machine. And this public IP is special, right? The only machine in the world who who has this IP is my AWS machine, right? That's what I mean by public IP. It's unique over the whole internet, and anyone in the world try to connect to this IP, they will connect to my AWS machine. I know that because AWS guarantees that it's my dedicated public IP that AWS assigned to me. So anyone in the world can browse this IP, HTTP, right? Then the IP address they can put. And the browser by default, they will speak to port 80. That is the default behavior of any browser in the world. They try to speak to port 80 of the machine, whichever they are connecting. So in this particular case, this is what happening. Anyone in the world who browse for this URL, for this URL, the browser will connect to port 80. That is the default browser behavior. HTTP default port is 80. And then Apache is listening there, right? When somebody connect on the server, Apache listens, Apache see somebody is connecting. Apache will serve the content of the www HTML folder to them. And you know what is that content? It's your application. It's your front-end application. So that is when in the browser you would see the web page. And this is how the websites are working. So let's see how it's working for us, right? Whatever website it is, this is the way how it works, right? So let's see how it is working for us. And it is working. Yes, you see some message, right? This is a simple application. It's not any complicated application, but yeah, you are able to see the application, right? Not directly on the browser. And this is a public URL. Anyone in the world can browse it. People sitting in US, people from Europe, people from India, right? Doesn't matter. They can browse and they will see this web page for sure. And that's the point, right? That's the whole point of setting up a web server. And this is the way how websites are working. Whether you browse google.com, facebook.com, right? So whatever website that you browse, technically in the background, this is what happens. Your browser speak to port 80 of the respective web server, and the respective web server will process the request and send you a response. And that is how you see the web page on your browser. So we have successfully set up a web application. CoIT frontend is a web application that we have configured using our AWS machine. We used a web server to serve this application to people. We also needed to open port number 80, which we just did, and now everything looks great, and you can see the web page, right? Great. And how the application communicates, right? That is something that we want to see. How they talk to each other. I'm not showing the practical side of it. Maybe you can do this as an assignment. How the application communicate each other. So in our particular case, we have three applications, and the browser want to speak to the front end application, or browser want to speak to Apache, the web server. Then the Java application want to speak to the Python application. Browser want to speak to the Java application. Let me explain you a little bit how my application is developed by my developers. I mean, how exactly this application is supposed to behave. I'll talk a little bit about that, right? My intention is that anyone in the world who browse for a public URL, they will get connected to my AWS machine. That's the first thing that you all are aware of. And then you will get a web page. And so technically, you have Apache that is running inside your AWS machine. It is one software running inside your AWS machine. Then you also have the CoIT, the Java application, right? Using Java jar command. Yesterday I stopped the machine, so I have to run that again, which we will do. So whatever, your Java application is running inside the same AWS machine, and it can be a different AWS machine also. In our case, we have been configuring everything on the same machine. So there are three softwares total running on my AWS machine: the Apache software, Java, and Python. So that is the case. And now when somebody browse on their browser, the first thing they speak to Apache. They speak to Apache on port 80, and then Apache will be serving them the web page, right? Apache will serve them the web page, and that is when you see this web page displayed on your browser, right? You can see the web page displayed on your browser. That is great. And now you try to type in something, assume test message or something. I try to type in and I click on the send button. Then what my application should do, or in other words, what my front end application should do when I click on the send button. The idea is that when somebody click on the send button, the browser would make a request to the Java application. And remember, Java application, it listen on port 8080. So technically, your browser has to make a connection to the AWS machine on port 8080. That is where the Java application is running. So that is something you have to do. And then after that, assume uh, once you typed in something and then you click on the send button, then some message, whatever message that you are typing in, it would be posted to some URL, some Java applications URL that would include port number as 8080, not 80. And then once this message is sent to the Java application, whatever message that the Java application receive, it will forward that message to the Python application. So Java application also want to speak to the Python application, and that configuration you already did. The URL that it will use is HTTP localhost colon 5000. That is because a Python application listen on 5000. So this is the URL which Java application uses to speak to Python and pass the message to Python. And then the Python program will do some processing and give some response. And finally, the response would become visible on the browser. So this is how my application is supposed to behave, right? So assume, it's a single software, but split into various microservices, and they are running as small applications. And when they want to communicate, they communicate using network, right? Java application want to speak to Python, it will use an HTTP URL. So using network, even though it is a local communication, still it uses a URL, right? Like a network thing. And then the browser want to speak to Apache, or the browser want to speak to the Java application. They all speak using some HTTP URL. For the browser, this is the URL. And when it comes to the Java application, the URL has to be port number 8080, right? You speak to, if you don't mention any port number, it will speak to port 80. If you mention any port number explicitly, then it will speak to 8080. So it is your developer's responsibility, whoever is developing this application, it is your developer responsibility that configure this send button, right? Configure this send button in such a way that when somebody click the send button, a request would be posted to this particular URL, right? Whatever URL that you have configured, and also pass that message, whatever you typed in the browser, pass that message to this application. That application then will speak to this application, where some processing will happen, and finally you will find a response in the browser. So this is the way how my application is configured. And different developers are working on different microservices because they are independent. The communication happen using network, right? There is no, otherwise there is no function calls or anything that happens between the application. Whenever they want to talk to each other, they talk to each other using some networking, and that's the point. So I am safe and I am good. So this should work. And there are two things actually. First of all, you have to tell Java application how to speak to Python application. In our particular case, we kind of already did, right? When we started the Java application, we passed this URL to the Java application as a variable, and now Java application already know how to speak to Python application. So that part we already did in the previous sessions. And then one more thing that I have to do, somebody click on the send button. Somebody click on the send button. The request should be posted here. So that is some changes that my developer has to do. My developer has to configure the send button on the front end, right? Send button, where the send button is in the front end, in the build folder. So my front end developer has to configure the send button to speak to the Java application. That is exactly what my developers has to do. I will show you the code, the respective code for the front end, right? This is the front end. Open the front end folder. And remember, the front end is now running on the customer browsers, and the send button is in the front end, right? It is in this folder, the front end developer write the code. Even the send button code is in here. So, and inside the app.js file, there is a file called app.js. You don't have to worry too much because it's your developer. You would give them the URL and they will do the rest. So, in the app.js file, there is a URL that we hard coded here. So, this URL has to be replaced with whatever the URL is of the backend, right? And in my particular case, it is this the public IP of the AWS machine, right? A public IP of the AWS machine colon 8080 colon 8080. That's the port number of Java service. So this is the URL I should configure for the send button. So anyone in the world click on the send button, the request would be sent back to my Java application. So I will be giving this URL to my developer, and my developer will do the rest, right? I mean, I am a DevOps engineer, or I am operating the application. I'm not developing the application. So what I have to do is I have to tell my developer, hey, this is the URL that you should use to speak to the Java application. Then my developer will make the adjustment inside their code, inside their front end code. That's what they will do. And also, what the another thing that they will do is they will they will do one more thing. They will, after making the code change, they will again run the command npm install, npm run build, create a new build folder, because every time the source code changes, you have to change the build folder also, right? So remember, you are changing the source code, your developers are changing the source code. When source code change, you have to again build it, combine with the dependencies, and then create the final build folder again. So you have to execute the npm run build command again. After the developer made the change, then only you will get the final build folder. So always remember, every time the code changes, you will repeat this process, npm install or maven install, or no, whatever code changes, you have to rebuild that application once again to create the final build, and then copy that build to the Apache document root. So one thing you have to remember, any source code changes should result in triggering of a new thing. So that's the whole point. And now this is how the communication works, right? So I'm not doing this is something for you to do. Whatever your URL is, you configure that, you run the npm run build, create the new build folder, and copy the new build folder to the www.html of Apache. And now you can verify when somebody click the send button using your browser itself. You can verify on your browser. You, after browsing for the front end application, you right click, you select this option, inspect on your browser. The browser has the capability to troubleshoot the front end. Any error in the front end, you can see it here. So in my particular case, let me try to type in something, and let me try to click on the send button. You click on the console on your over here, click on the console, and then try to click the send button. You will see some error over here. The error says connection refused. Obviously, you can see the request is going to some wrong URL, not to port 8080. This is some wrong URL the request is going to. That need to be corrected, right? That need to be fixed. So That's the whole point. You can actually see. So after you made the code change in the app.js file, after you rebuild, right, npm run build command, the new build folder you copy to the Apache, it would consist of the correct URL. So when after that you click on the send button, it should be sending the request to the new URL. So you make sure that that works, right? In your browser console you see that URL, but you might not, you might still get some error. That is okay, you ignore that error. But when you click the send button in your browser console, the URL should show correctly, the new URL whatever you put in the app.js. So that's the whole point. And once that part is done, your assignment is complete. Just try to do it. Try to configure your front end app.js to speak to the Java applications, and let's see. Great. Now let's talk about the importance of automation on doing all this process. So we did many things. We developer modified the code. We built the source code, created the executable code, and then we have run those executable code inside a server. Sometimes it's one server, or sometimes it could be a multiple server, or sometimes it could be a cluster that you want to run, or sometimes it's Kubernetes if you are using Kubernetes. So technically, I mean, on a high level, I will tell you what happens inside a company continuously and why you should automate that process, right? I mean, for every company, there are a bunch of process that happens, right? First of all, you modify the code. Your developer keep on modifying the code, and when the code get modified or after the code got modified, the next thing what you want to do is you want to build the code into some executable files. You want to create some kind of executable code, or you call them artifacts. You have to create the artifacts. The executable code is what you have to create next. Then after that, what is the next step? You want to store those artifacts somewhere, something that we didn't discuss. For now, all the artifacts are stored within the AWS machine. That is okay for now, right? So we have been doing everything inside an AWS machine. After creating the artifact, we store those artifacts. In our particular case, our same AWS machine, we kept the artifacts. But in real time, the companies, after they created this build folder, after they created the jar file, they will copy those files in some central storage location, from which anyone in your team can download them and use them, right? And then after that, you want to deploy your surveys or deploy the infrastructure. What that means is a set of machine where you want to run your software. So these four process keeps happening inside a company, right? Your developer keep on making the code change. They write some code, they added some new functionality in the software, and then the code got tested. No, then the code is built into artifacts. Then the artifacts are stored somewhere, either locally or remotely. Then after that, you deployed your application. You install those new artifacts into the machines, and then you tested your software. Then you notice that there are some issues. Now the developer has to fix that issue. So they will again make the code change. They will fix it, and again they will push it. And then again you want to create the artifact. You want to store them. You want to deploy them. So in our particular case, the code change, you already know the developer do it on their laptop. Creating artifact, it depends on the technology. If it is front-end application, npm install and npm run build command will do. These two commands is what we are using for the front-end application. If it is back-end application, we use maven install. So these are various commands that in our particular case we are using. But yeah, depends on the company and depends on the technology. The commands may vary, but the work won't vary, right? It's same. So this is what a company has to do. After the code got changed, they want to create the artifact, and then after that they want to store those artifacts. Maybe in the cloud they want to store those artifacts in some cloud storage. So there is this build folder, there is this jar file, there is various executable file that your company has built from the source code. You want to store them in a common storage, and then finally you want to run the software across one machine. In our case it's one machine, but in real time it could be across multiple machines that you want to run them. So always remember, this for process keeps repeating inside your project, right? It keeps repeating inside your project. Always, you always do this. That's what you do most of the time, right? And that is why this process should be automated, right? You should not be manually running the npm install command or maven install command. It should be configured to run automatically. You won't be storing those jar file in a common storage. You won't be copying them manually. It should be automatically copied. You won't be installing them inside the machine. It should be automatically installed. Basically, in about few minutes, all these things should happen right after your developer made a code change. The developer make a code change, then within few minutes, the software would start running inside your infrastructure, and then the developer get a preview. And this is important. This is one of the core DevOps principle. Your developer get quick feedback, after all this process have been completed. And today we are not automating it. We did it manually, and we will continue to do it manually for some time. At some point we will automate it later, not now, but you got the point, right? That's what we will focus on in the later on in our advanced training. But you have to remember this process should be automated. Your developer should be writing the code and putting their code somewhere. And as soon as they finish writing the code, this process should begin, and this whole process should be automated by the machines, and not a single human needs to get involved in this process. Then within few minutes, the developer gets the feedback about the code change that they did. If there is any error in creating artifact, if there is any error in storing artifact, if there is any error while installing the software, or if there is any other testing that you may want to run, so any error in the testing, so all the problem that ever happens will be immediately reported. So developer get quick feedback within minutes if you automated this process in a faster way. And that is important. You have to remember always, right? This automation may happen within developer laptop, or most companies set up continuous integration using Jenkins or using some tools that which they will set up in the cloud. That tool will do the automation, right? Who do the automation is not important. What is important, what DevOps strongly suggest you, is that this must be automated, and the developer should get a preview immediately after they finish the code change. And it is important, right? It's one of the most important DevOps principles, right? Great. And like I said, I'm not getting into any technical depth of this. We are not going to automate it today. We'll do it later, but you have to always remember this, how it is done inside the companies. It's not a manual job, right? It's an automated job. Great. So, how your infrastructure look like in real time. I mean, something that I want to discuss as well. So in our particular case, we run all the three software: the Python application, the Java application, and the front end application. But there is one problem. We run everything in a single machine, and that is how the companies do it. The companies create multiple machine in their production infrastructure, production, or any other infrastructure also. It won't be a single machine where you want to run your software, but it would be rather a bunch of machine where you want to run the software, because of various reasons. Sometimes you want to scale your software, right? The traffic does not won't be same all the time. The traffic may increase or decrease, so you might want to increase the number of the machines where you want to run the software, or decrease the number. Maybe the front end application itself you want to run in 3 machine, the Java application you want to run in 10 machine, the Python application 15 machine. So probably you don't know, you don't know the size of the machine that you want. So definitely you will keep more than one machine sometimes to run your application. So in such case, the real infrastructure look much different than what we have set up, right? So what we have set up, we created a single machine, and on the same machine we have set up all the software, right? We created one single machine. It's an AWS machine that we have set up, and on the same machine 3 softwares are running. One is the front end, the other one is the back end, and other one is the Python application, right? Three application we run on the same machine. Sometimes it can be like this, one machine for one application. If you, for the second application, you create a second machine, and for the third application you will create a third machine. So this is also an option that you can do. Maybe the front end you will run here, the Apache, right? Apache you will run here, then the Java application you will run here, the Python application you will run here, and then assume this machine has an IP, this machine has an IP, and this machine has an IP, and both of these machines should have a public IP, right? This machine, because the people from all over the world, they want to speak to the machines from the browser. So yes, these two machines need a public IP. So this machine, when browser want to speak to Apache, it will speak to this public IP. When a browser want to speak to Java, it will speak to this public IP on port number 8000 8080. And when this application Java want to speak to the Python application, it will speak to the port number of 5000 of a this IP. It does not has to be private, public IP. It can be a private IP also, because the Python application, as I know, as you know, it is an internal application. Browser don't want to directly talk to it. So if there is a private IP, that is sufficient. These two machines should have network connectivity between each other. Browser or people all over the world don't want to speak to Python. Only this machine want to speak to Python. So as long as these two machines are able to communicate each other, that is enough, because Python application is like that. It's an internal application connected only from the Java. So Java server should have the ability to speak to Python server. Otherwise, for that it can use a private IP instead of using a public IP if they are connected on a private network to each other. So that is possible. So this could be how it will look like in real time. A three application in three separate machine, and every application will have its own URL. Or sometimes it could be much more complicated. Maybe you would run 3 or 4 machines per application. Front end application will run in 3 machines. The backend application will run in 3 machines. Python application may run in 5 machines. So, right, in every machine you will run the application. So, total 3 machines running the CoIT front end application, 3 machines running the backend, and 5 machines running the Python. So, that is also could be the case. As then, for a single point of communication, all the machine run front end, all the 3 machines run Apache, all the 3 machines run the Java jar command, Java application, all machine run the Python program. So which machine will be serving all the machine equally? So to make sure of that, what you generally do is you place a load balancer in front of every service. In front of the Python service, you keep a load balancer. In front of the Java service, you keep a load balancer. In front of the Apache, you keep a load balancer. So what that means is the communication will happen to the load balancer. In this particular case, assume your customers, they want to speak to the Apache, they will speak to this load balancer, and that load balancer will send the traffic back to one of the backend machines. And then the browser want to speak to the Java application, it will speak to this load balancer. Load balancer will route the traffic to any one of the backend machines. And similarly, when these applications want to speak to the Python, they will speak to the Python load balancer. And then this load balancer will send the request back to any one of the backend. You got the point. The point what I'm trying to make here is that the infrastructure can be this much complicated. It can consist of a number of machine load balances, and they might be working together in order to serve the whole system. So all the machines run the front end, all the machines run the Java, all the machines run Python. And then when they want to talk to each other, there should be a single point of communication, and you would be creating a load balancer for that. All cloud providers allow you to create load balancers, or if you want to set up load balancer all by yourself, that is also a possibility. So in such case, you would need a load balancer to be placed in front of the machines, and that is important. So this way the communication works. This is how a real infrastructure could look like. So in this particular case, in all these machines, you have to copy the build folder and run Apache. In all these machines, you have to copy the jar file and execute that jar file. In all these machines, you want to copy the Python program, install the module, and execute the Python program. So your work will also progressively increase, right? Previously it was only times you had to do. Now it is total 3 plus 3 plus 5, 11 times you have to repeat, right? So this is something that you will as your infrastructure become complicated, your headaches would also become complicated. You are managing the infrastructure can also become complicated. But this is just an overview that in real time the infrastructure can be complicated. Think about Google. It may not be three, it might be 3,000 or 30,000 or maybe 3 lakhs. There can be a huge number of machine behind a load balancer of Google, and that could be the real case, right? There can be a huge machines running the same software because they are expecting huge traffic, a lot of people connecting it. One machine cannot handle everything, so there should be multiple machine. In case one machine fail, there should be backup. So there would be a lot of the infrastructure can be much complicated than uh, running a single machine, right? It all depends on the company size, depend on the software complexity and many other factors. The infrastructure can be complicated, and when infrastructure become complicated, your work will also become complicated, right? So always remember this. Great. And with that, we will stop talking about the traditional infrastructure, right? We are going to talk about the traditional infrastructure, and we are going to start a new way of working using the containers. So we are going to talk about the containers. So let's talk about containers. Great.